So we're on page 42, and we're looking at solving linear systems. And here are a couple of examples that we're going to do. We're going to do number 1 and number 2 on page 42 and go over them. So we start with number 1. We want to solve the linear system 7x plus 2y equals 8. 2x plus y equals minus 2, which means that we really want to find the x and y values where these two lines intersect. If these two lines are not parallel, because parallel lines don't intersect, if they're not parallel, they have to intersect at some point. So one of the ways that we learned to do this was to do the elimination method. So first of all, we're going to number the equations 1 and 2, and we're going to change equation 2 and eliminate the y. And you can see here, it's easier to, because 7 and 2, to make those two numbers the same, is probably a little more complicated. We have to multiply this one by 7 and this one by 2, but this one here, so we'd have to multiply each equation. But here we only have to multiply this one by minus 2, and we would get minus 2 over here. And then when we add these terms, they would come to 0. So we're going to multiply equation number 2 by minus 2. So minus 2 times 2x becomes minus 4x. Minus 2 times plus y gives us minus 2y. There's an implied 1 in front of the y, so plus minus 2 times plus 1y gives us minus 2y. And then minus 2 times minus 2 gives us plus 4. So what we're doing is taking equation 2 and multiplying each term by minus 2. Why do we do that? Because when we add the y terms, they will sum to 0. So we're eliminating the y. Yes, we can eliminate the x, but in this case, we think it's easier to eliminate the y. So we leave equation 1 the same. That doesn't change. And we multiply equation 2 by minus 2 to make this term into minus 2y, so that when we add the two terms, they will come to 0. So here's equation 2, as we've explained, multiplied through by minus 2. And now we can eliminate the y by adding the plus 2y, and the minus 2y gives us 0. We don't write anything here. 7x minus 4x is 3x, and 8 plus 4 gives us 12, so we know x is equal to 4. Now we substitute x equal to 4 into equation 1. We could substitute it into equation 2. It doesn't really make any difference. But we're going to substitute x equal to 4 into this equation right here. So, and replace the x with a 4. So 7 times x, where x is 4, plus 2 times y equals 8. The reason we're doing this, we have the x value, but we don't have the y value. So we're going to put the x equal 4 into equation 1, and then substitute, and then solve for the y. So 7x plus 2y equals 8. We replace the x with the 4 right here. We get 7 times 4 is 28 plus 2y. And we transpose the 28 from the left to the right. 8 minus 28 gives us minus 20. So y equals minus 10. So we know that the ordered pair that fits on both lines is 4, minus 10. 4, minus 10. Now there is a way of checking this, and that is to work on the left side with x equal to 4 and y equal to minus 10 right here. Go back always to the original equations. 7 times 4 plus 2 times minus 10. So that's 28 minus 20 gives us 8. And the right side is 8. Now let's go over to this equation. 2x, where x is 4, is 8. 8. And for the y, we're going to substitute minus 10. 8 minus 10, right here, gives us minus 2. So that proves that the solution set 4 minus 10, that point lies on both lines and for the intersection of both lines. Now, you'll notice that when we did this problem, we modified only equation 2. We can also modify both equations in a system if necessary in order to eliminate a variable. So there are going to be occasions where we have to multiply both equations by a coefficient. In this one, we didn't have to. We only had to multiply equation 2 by a coefficient in order to be able to eliminate the y. Another application in order to do the solution is we're told in the sense from a word problem, the sum of two numbers is 48. So if we let x be the first number and y the second number, x plus y equals 84. The sum of two numbers is 84. And the difference between them, in other words, if we subtract y from x, is 42. So we have the sum of the numbers and we have the difference of the numbers. Difference means if we subtract one from the other. So x minus y is 42 and x plus y equals 84. There should be a number 2 here, but we really don't need it here. This is equation 2. I think it's important to number the equations. So I left out the number 2 here. So when I add the y's, of course they sum to 0. When I add the x's, they sum to 2x. 84 and 42 is 126. I divide 2x by 2, I get x. I divide 126 by 2, I get 63. So my x is 63. Now I put it back, substitute the x equals 63 into 1, and I get 63 plus y equals 84. 63 plus y equals 84. I transpose the 63 from the left to the right. It becomes minus. So 84 minus 63 is 21. So the two numbers must be 63 and 21. And notice when we subtract 21 from 63, we get 42. So here we check that x plus y, 63 plus 21 gives us 84. Here we do the subtraction, we get 42. And so we know that we have the right values. If both of these have to work out, so the sum of the two numbers must have to equal 84, and 63 minus 21 has to equal 42. Now, let me just say that if you graphed x plus y equals 84, and you graphed x minus y equals 42, the point of intersection would be 63, 21. Now you can see that would be hard to graph because you need to make your divisions correctly. Point of intersection would be 63, 21, but you still could get the solution graphically. It's just much easier to do it algebraically as we've done. So let's just go back and review what we did here. We showed two equations, and we showed that method of elimination to get the variables. The method of elimination is not the only method. We can use substitution, but elimination is probably the more frequently used